taking a bit of a turn here and digging into how we deal with wood and biogenic carbon in life cycle inventories and life cycle assessment tools. Just a little bit about me. I'm a consulting director within sustainability at Sphera, formerly ThinkStep, so we were purchased last year by Sphera. My background's in structural engineering, but kind of more relevant to the audience here, I've helped provide the background data for the tally tool. I've also contributed to the LCA data in quartz, and I have been a LCA practitioner for the last 7 years. So before I get into what's happening in tools, I want to make sure we're all using the same terminology correctly and that you know what I'm referring to when I talk about lifecycle inventories and lifecycle impacts. So lifecycle inventory can be used to describe both the inputs and outputs associated with conducting an LCA, so the electricity use, the material use, etc. But when that gets combined with the background data, which is something I'm going to go into later, some of the background data sources, you get a list of inputs and outputs at a resource level and at an emissions level. And that's what we call the lifecycle inventory. These are the list of elementary flows or exchanges, depending on which software you're using. And so when I say lifecycle inventory moving forward, this is what I mean. It's a very detailed, long list of resources and emissions. The lifecycle impact assessment takes those emissions or resources, depending on the methodology and category you're looking at, and characterizes them based on their ability to, in this case, increase radiative forcing, and that creates global warming potential. And then there's other impact potentials that can be talked about as well. But when I'm talking about life cycle impact assessments, I'm really talking about the global warming potential. So it's after it's been characterized into global warming potential. And just this to demonstrate, here's our inventory value, here's our characterization factor, and then the impact potential. So elementary flow or exchange is the life cycle inventory value, and the kilograms of CO2 equivalent, or the GWP, is the life cycle impact assessment result. So you might say LCIA result or LCA result. Both of those are kind of interchangeable. So what I'm going to talk about today, and my animation got a little messed up, is the LCA software. So there's a few solutions there. I'm also going to talk about LCI databases, so databases of lifecycle inventories. I'm going to talk about LCA tools, so tools that make use of LCA results. I'm not going to talk about LCA, LCIA databases, but I did want you to know that those do exist, basically, and EC3 is kind of one of those as well. As you can go and look at a database of the life cycle impact assessment results, or GWP results in the case of EC3. Quartz, however, is one of the more well-known ones, but it's currently suspended, so I'm not going to dig into that. So for the lifecycle inventory software or lifecycle assessment software, they can kind of be exchanged. There's kind of 4 big players: GaBi, which is created by Sphera, formerly ThinkStep, my company. So it's the one I am the most familiar with. CIMAPRO, OpenLCA, and Umberto. The characteristics associated with the lifecycle inventory software, lifecycle assessment software, is that they can use multiple lifecycle inventory databases. So there's not necessarily any assurance of consistency within the data within a software tool. It's depending on who's using it, what data you can enter into it, what data you've purchased, etc. All of these software tools require an experienced LCA practitioner, because ultimately the methodological decisions are up to the practitioner. So how you treat biogenic carbon is going to be up to the person doing the LCA. Like I said, I'm the most familiar with GaBi. It's what I use daily. So I'm just giving some examples of what the software or database data sets look like within GaBi. So you see here on the left, we've got the basically inputs up on the top and outputs associated with a cubic meter of softwood plywood. You can see we have renewable resources of carbon dioxide coming in, so that accounts for the uptake of the wood as it's being grown. And I'll dig a little bit more into what goes behind data sets later. And then we have a very long list of outputs. If you scroll down, you would get to carbon dioxide from fossil sources, carbon dioxide from biotic sources or biogenic sources. But within the tool, you can apply any impact assessment methodology you want, whatever the tool has implemented, or you can even implement your own methodology. The thing to note here is you can include or exclude biogenic carbon, you can include or exclude land use change, you could even use outdated factors. So it's really important that the LCA practitioner that's using the software is aware of what methodology they're selecting and why, and is the data that they're modeling applicable to that methodology. So have you looked into the land use changes associated with your product system? If not, then using this land use change or including land use change in your impact assessment methodology may not be entirely accurate. And then the other thing to note is that the software includes flows or exchanges, which is basically the reference flow for the product that typically includes details on the carbon contents of products, but those carbon contents don't necessarily factor into the final GWP calculation. Depends on how you implement it in the tool. So you can have an LCA software, but it could be empty. There could be no data in it. So you need databases within the software. GaBi is also, while it's the name of the software, it's also the name of the database that goes in the software. There's also EcoInvent and US Lifecycle Inventory or the federal LCA Commons. These are just some of them. There are other ones out there. You could implement, like, for example, EcoInvent and US LCI databases are all available in the GaBi software, but GaBi databases tend not to be available in other software, although you can use them in Umberto. So there's different variations of how you can access it. So like I said, it's a life cycle inventory, so it's listing the emissions and the resources. So they all separate out carbon dioxide between fossil and biogenic, and same with methane. And there's different ways they can refer to it. So in GaBi, they call it carbon dioxide biogenic. In EcoInvent, they call it carbon dioxide non-fossil. It's the same thing. They also have natural resource inputs, so it's carbon dioxide from air or just carbon that's in the soil. It depends on the nomenclature of the database. And like I said in the previous slide, elemental composition is a property of the flow, but it doesn't actually contribute to the final impacts. So you can use it to ensure carbon balance in your model, which is what I'm going to get into next. There are a lot of challenges. I mean, this whole series has talked about the challenges of modeling biogenic carbon. When I talk about it in LCA software, I'm most often referring to just a product life cycle assessment, so a cubic meter of lumber. Ultimately, there's still a lot of challenges. You know, the person you're collecting data from isn't tracking all the carbon-containing flows. The biomass carbon contents will vary depending on moisture content and many things. So we often use average values. Ultimately, you may have to do an allocation between co-products at a facility, and that would mean that the carbon will actually not balance. So when I say carbon balance, we basically want the input of carbon to equal the output of carbon. It has to go somewhere. So the most often used approach, at least in the GaBi software, or what's applied by my colleagues at Sphera, and the typical approach within LCA modeling in general, is to find out the biogenic carbon content of the final product and then manually adjust the model so that you know how much carbon is coming in, you know how much carbon is contained in the product, and the difference has to be released somewhere or contained somewhere. So there is an effort made to map where the carbon goes. One thing to note is that carbon is only carbon neutral if all the CO2 that was removed is also released as CO2. So when we talk about carbon, we always convert carbon coming into the carbon dioxide equivalent, so based on the molecular weight of CO2. If it's then released, you know, if you incinerate the wood and it's released as CO2, then it's basically carbon neutral. The carbon uptake is equal to the carbon release. However, if the carbon containing product rots and it gets transformed to methane, then it's not carbon neutral. There's a much higher impact associated with the carbon that's released as methane rather than the carbon released as carbon dioxide. It's important to do the proper accounting and tracking of carbon in your product when you're doing an LCA, because you may be inaccurately capturing an emission or you know, a source or a sink in your product system. But that accounting is very challenging, so often back calculating is done. So we know that it has to balance, so let's make some assumptions along the way. One thing I wanted to point out is that when you're excluding, so the global warming potential impact assessment methodologies often have GWP including biogenic carbon and GWP excluding biogenic carbon. One thing to note is that GWP excluding biogenic carbon is still including biogenic methane because it wants to account for the increased impact that biogenic carbon has if it is released as biogenic methane. So I just wanted to point that out here for everybody's reference. And Tracy 2.1 is still currently referring to the previous version of IPCC, so I also put the latest IPCC values in, which we'll be updating soon, hopefully. So the last kind of area I wanted to cover was the LCA tools for buildings. Again, this is not necessarily an exhaustive list, but see, there's some of the more prominent ones. Tally, Athena Impact Estimator for buildings, one-click LCA, and then EC3. So the characteristics associated with these tools are that they only are looking at impact assessment results. So they don't have the complete life cycle inventory. The impact categories being looked at are selected by the tool creator or the source of the data. So if the data is coming from an EPD, you're limited to what the EPD declared in it. Still though, the interpretation of the results is going to be up to the user of the tool. The tool may give guidance on how to interpret it, but there still needs to be some basic understanding of what LCA is, what assumptions are being made, etc. when you conduct an LCA, even if it's very, very simple LCA. So here's a table kind of doing an overview of the tool, the data source, the LCA methodology, and how they treat biogenic carbon. Tally uses GaBi data and EPDs conducted using GaBi data to ensure that the background data is consistent, uses Tracy 2.1, and it includes both includes and excludes biogenic carbon. So the user can choose. EC3 has publicly available EPDs. Usually the EPDs are referring to Tracy 2.1, but that could change depending on the EPD's year of release. And it made estimates to include biogenic carbon if it wasn't provided by the EPD. Athena includes biogenic carbon in their EPDs, while one-click LCA uses a variety of background data sources. I actually have not used this tool. I haven't used most of these tools because I use GaBi, but it seems a little bit unclear whether they do or do not include biogenic carbon, although I imagine that they make some estimates to include it where needed so that they can have consistency across their data. A couple things I wanted to note is that, you know, we've talked a lot about forest carbon stocks. Inclusion or exclusion of things like forest management and land use data or land use change, whether it's direct or indirect, depends on the background data and the assumptions made in the LCA used to create that background data. So ISO 21930 does give some guidance around that, and sustainably managed forests can be counted as having zero emissions from land use change. Ultimately, selection of the GWP indicator is up to the LCA practitioner in EPDs, but if you do include biogenic carbon, you have to provide additional details on the emissions and removals over the lifetime of the product. And with a minute left, my conclusions. LCA software and LCI databases allow the practitioner to choose whether to include biogenic carbon or not, but even if you've included it, you still need to make sure you're accurately modeling the carbon flow. So it's really, there is opportunity for error in there. The system boundaries for lifecycle inventory data will vary, and the practitioner should review the assumptions of the data when they're selecting them. So if you want to include land use change, you have to make sure that the data sets you're selecting have also included land use change. And finally, LCA tools usually make that decision for the user, but it's still important to, some tools do allow you for you to make the distinction, and ultimately it's still important for users of these tools to understand LCA and have some education about the decisions they're making. Thank you.